Debunking Myths About How People Learn by Rebecca King Kahukom. Based on the Committee on Developments in the Science of Learning, the fields of neuroscience and cognitive science are helping each other to help answer about how people think and learn. The following are the 3 myths which were not given importance in classroom practice of how people learn. First, the left and right hemispheres must be taught separately to maximize learning. Next, the brain grows in holistic squares within or around which specific educational objectives should be arranged. Third, the people use only 20% of their brains, with different percentage figures in different incarnations, and should be able to use more of it. Reviews were made on the key findings from neuroscience and cognitive science. These were the basic concepts of neuroscience about brain development, including effects of instruction and learning. Second, learning as an example of mind-brain connection. The third, how memory is represented in the brain and its implications for learning. Let me explain how neuroscience discusses it. Looking at the image below, the large things here are called neurons. The branches are dendrites. The glowing areas are the synapses which link the neurons. Neurons use neurotransmitters to pass information from dendrites to another. That is, when one learns, the brain makes new connections. Upon learning new information, the brain makes new connections by having new grown dendrites, called neural plasticity. That is, the changes in neural pathways and synapses, thereby letting one perform its tasks. So this is how the brain works. Findings were discussed on the following. First, the role and effects of instruction about brain development. Language processes contribute to organizing the brain. For example, deaf people learn a sign language to communicate using visual system instead of their auditory. Not all deaf people use the sign language due to different language experience. Second is the mind-brain connection is called learning. Human brain can be functionally reorganized by instruction after suffering from stroke or portions of the brain being removed. To regain lost functions, instructions are provided for long periods of practice. Such is what happened to Melison's removal of his hippocampus, which resulted to forming new motor memories. The memory says the mind is not just a passive recorder of events. Rather, it is actively at work both in storing and recalling information. Such is why experiences are remembered well or poorly. There are 3 main points discussed based on the key findings from neuroscience and cognitive science. First, learning changes the physical structure of the brain. Second, learning organizes and reorganizes the brain. And third, the different parts of the brain may be ready to learn at different times. On the other hand, As for Carey's brain, he states that learning is a restless exercise. And the restlessness applies not only to the timing of study sessions, but also to their content. For example, the value of mixing up old and new material in a single sitting.